So when we move on in our decimal discussion, today we're going to focus on subtraction. And subtraction is very similar to addition. And once again, it's the same as subtracting any numbers, and basically as long as you remember to line up the decimal place. Let's try some examples to this, because some of them they can be tricky. Let's look right here. Let's look at the first few. And you'll see what I mean pretty quickly when I show you how they can be tricky. Like this one here, for example. If I have 6.4 minus 4.52, well, first of all, we notice that there's a 6 and a 4, so they can be subtracted, because the first number is larger than the second one, so it's no problem. But I'm going to write them down like I was saying before, putting them one above the other one, and keeping our decimals in order. So it's going to look like this. So number one right here looks like this. 6.4 minus 4, keeping the decimals in line. Notice when I'm keeping the decimals in line. 4.52. And let's start subtracting. And when you look at this question now, as we start subtracting, first thing you're going to notice is, I can't, what about the 2? What do I do with that? There's nothing above it. There's no number to subtract them from. When you have a situation like that, you can take your 0 and put a 0 in there. I'm going to actually take that out and put a different use of color. So you can put a 0 in there by yourself, and there you go. Now it's the same subtraction as normal subtraction would be. You just take one, borrow 1 from the 4, or borrow 10 from the 4, it becomes a 10. So now it's 10 minus 2 gives us 8. And this becomes a 3. 3 minus 5, we got to borrow again. So we borrow from the 6, that becomes a 5, 13. And 13 minus 5 gives us 8. The decimal place just drops straight down. And 5 minus 4 gives us 1. Alright, pretty cool. Number 2 looks kind of confusing when you first see it as well. We have 50.4, so number 2 down here. Minus 5.24. So it's the same as before. Notice it makes a difference where you write the decimal, right? If I wasn't careful with the decimal, I could write it like this and easily make a mistake. I could go 0.4 minus 5.24. That's a common mistake. Subtract the 4's and this, but it's not right, so you can't do that. Make sure you line the decimals up before you do anything. And so once again down here, I'm going to put in a 0, and then borrow from the 4 here. That makes it a 3. So that gives me 10 minus 4, it gives me 6. 3 minus 2 gives me 1. I can't subtract 5 from 0, so I'm going to borrow again. So once you get out the subtraction, actual subtraction, it's the same as always. 10 minus 5 gives us 5, and 4 we have right here. And the decimal slides right down there. Awesome. Number 3, I'm doing these because they're kind of odd looking numbers, or odd looking questions. So we had 25. 25 minus, now this is a mess. This is interesting, like there's no decimal here. Oh, I hate when that happens. Well, there's no decimal there, so we can put our own decimal there, right here, behind the 25. Now we know where to line up the bottom. The bottom goes 0, the decimal goes in here. We have 7, 5, 4. Alright, looks like fun. This is why calculators were invented. If you don't want to do it the long way, but just put in your calculator, you'll be fine. But we're going to do it the long way just for practice. 0, 0, 0. I can't subtract 4 from 0, so I'm going to borrow from this 5, believe it or not. This comes at 4. This becomes a 10. Borrow again, make that a 9. There's a 10. Borrow again, make that a 9. And this becomes a 10. So I had to borrow way over to the 5. And then I'm subtracting. 10 minus 4 gives us 6. 9 minus 5 gives us 4. 9 minus 7 gives us a 2. And the 4 pops down, and the 2 pops down. And that's it. How do we feel about those? Doing pretty good. It's the same as addition. As long as you don't line up your decimals, it's just the same as the normal subtraction you did in school. Alright, moving along. Multiplication of decimals. Just going to cut this out, put this in your notes. This is a little tricky, but it's not bad, but it's like a little trickier than just add and subtract. And sometimes the description of it makes it sound more confusing than the actual process. It says to multiply decimals, use the same process as in whole numbers, whole number multiplication, but do not line up the decimals in the decimal multiplication. The decimal places are counted, not aligned. What? Counted? So, for example, they use 4.75 and 0.4. They wrote them vertically, right in here. And then multiply the two numbers together. Remember, multiplying these numbers, we go 4 times this one, 4 times this one, 4 times this one, right? Remember way back in the day when we used to do it by hand? The days before calculators. And then count the total number of decimal places. What do you mean by decimal places? So what we mean by decimal places, we had a discussion about decimal places before. When we talk about decimal places, if I have 4.75, 4.75, then I have two numbers on the right hand side of the decimal, or behind the decimal, or after the decimal, whatever way you want to think about it. So this has two decimal places. And we have 0.4, 0.4, and that has one decimal place. So we add up the decimal places, we actually get 3 decimal places. Now how does that affect our answer? Because we get an answer like 1900. Looks like this. We have 19. I'm going to put a decimal here for a second. We have 1900. 1900. Decimals right. Oops, my bad. Not that far back. Oh, yeah. Try it again. 1900. So we have a decimal right here. It's behind there. We see the 3 decimal places. Oops. What we do is we take the decimal, take the decimal and move it over 3 places. So we go 1, 2, 3, move over 3 places. That makes sense? Let's do some examples of those. Bring in the pen working again. There we go. So, back to our book. Let's look at some examples of those. 13. Let's look at look at the simple one first. This one here. So take this one here, hit 12.5, multiply by 3. Pretty simple first to start off with. So we break these vertically. So we have 12.5 multiplied by 3. So now multiplying here is going to be the same as multiplying all in the other way. It's going to be 3 times 5, so it's going to be 15. 5 carry 1. 3 times 2 is 6, plus 1 is 7, and 3 times 1 is 3. And that's what it works out like. And we notice here that we have one decimal place right here. So we put a decimal right there over one decimal place. Oh, cool. Alright, let's try something a little more challenging. I'll give you a second just to give a head start on that one. Try it yourself. Just take a second. This is question 7, just to be clear. And the number is 6.74. Okay, so if I go solving this one, 2 times 4 is going to give me 8. And 2 times 7 is going to be 14. 4, I will carry 1. 2 times 6 is 12, plus 1 is going to be 13. And the next one I'm going to go 1 times 4 is 4, and 7, and 6. And I'm done. Are good? Looking good so far? Are we sure I'm looking good? Or am I trying to trick you? Something wrong. You want to see what's wrong? 7 screws are fine. It's one mistake though. Right, not lined up correctly. It should be over here. It should be here. Because when I go to the next number down here, the 2 times 4 is 8, 2 times 7 is 14, fine. When I go to the 1, I gotta move over one place. Don't forget that little shifting along there in one place over. And then I can add them up and I'm good to go. So I have 8 plus 0 gives me 8, 4 plus 4 gives me 8, 7 plus 3 gives me 10, it's 0 and I carry 1, and 6 and 2 is 8. Now, check this out. The thing we got to be concerned with is how many decimal places do we have in this multiplication. We have 2 numbers behind the decimal up here, 2 numbers behind the decimal down here, so we have 4 decimal places. This is important because it tells us where the decimal down here has to go. So basically now I take the decimal down here and I go 1, 2, 3, 4, and I put a 0 in front. And we're good. If you want to double check that, we can use our calculator, which is nice, handy to have by. I like this digital calculator thing, it's pretty neat. Pop it up anywhere I need. So if I were to do it in the calculator, it looks like this. 6.74 multiplied by 0.12, and we get decimal 8088. So you can see it works out exactly right. But if we didn't consider the decimal places, we wouldn't have the decimal place in the right spot in our answer. So it's very important to consider the decimal places when you do multiplication with decimals. Are you okay with that stuff? All right. Do you want to see another multiplication, or do you want to move on to division? One more multiplication. Okay. When in doubt, do another one. Let's try. Number 10. So number 10 we have 4.79 multiplied by 2.2. You notice we don't have to line the decimals up for multiplication because it doesn't really matter. So starting our multiplication, I'm going to multiply these two first. I'm going to go 2 times 9. Oops, change color. 0. Change color. I'll just erase it. So I'm going to go 2 times 9, 2 times 7, 2 times 4, and so on. So 2 times 9 gives me 18. Put an 8 down, carry the 1. 2 7s are 14. 1 is 15, so I'll put my 5 down, carry my 1 again. And I go again. I'm going to have 2 times 4 is 8, plus 1 is 9. This time I'm not going to forget to move over 1 because it'll put a 0 right here. And because it's 2, it's going to be the same numbers. 8, 5, 9. Oh, what? Well, 2 times 9 is 18. Down here, it's the same game. So I'm just kind of like breezing through that. I'm going to add them together. I get 8 plus 0 gives me 8. 8 and 5 is 13. Carry the 1. 10 and 5 is 15. Carry the 1. Now I have 10. Nailed it. Or did I? I finished it? No. So, what do I have to consider now? Sorry, what did you say? Exactly, the decimal places. So up here, I notice there's 1, 2, 3. So 3, total of 3 decimal places in our multiplication. So I have my decimal right here. I'm going to take it, move it down, and go 1, 2, 3. It goes in right there. Ten 1.53. Let's see one more. You good? Sure. Yours or mine?
Mine here.
I've seen so many different calculators in so many different places. And I know usually I can tell the ones that have the reset button behind. So any desk calculator, push the reset button, bang, and then it puts back them factory settings. All right, no problem. So that's multiplication. And in the meantime, you do have your calculator, so you can use your calculator. But I mean, I want to show you how to do it, because you know, you never know, you may not have a calculator at some point. You might need to make this calculation. So, next piece, our favorite, second favorite thing next to fractions. My sarcasm is over the top. The long division of decimals. Ah, the only thing worse than long division of decimals is long division of polynomials. It's worse. So, let's look at decimals. I'm gonna see if I can put that in your notes for you. I'm gonna copy that over. Here we go. In there. So, to divide decimals, one needs to place the decimal point first and then divide the numbers. Once the decimal point is placed, it is not moved, and the students have a tendency to want to move the decimal point once this process is underway. The result will be an error. And what do you mean, place the decimal point? You don't even have it kind of done down here the way I would do it. So if you look down here, right? What I really want to see is I want to see, if you're dividing those numbers, it's going to be 6 divided into 2 decimal 5 8, and the decimal point that's there, it shifted right up above to here. Okay, and then I just start dividing. Well, 6 cannot divide into 2, so that's where the 0 comes from. And then you look at 25. 6 and 25 4 times, and 4 times 6 gives me 24. And I subtract, which gives me 1. The 8 pops down, and then I give it 3. 3 times the 16, 6 gives me 18. And I have a 0 when I subtract. So the answer would be 0.43. And if I put in my calculator just to double check, you will see that if I have 2.58 divided by 6 gives me 0.43. But the biggest secret of long division is this piece right here. Make sure you have your decimals behind up, one above the other one, in your divisor. Alright, let's try a couple of examples of those. So let's divide 44.35 divided by 6. Round to the nearest thousandth if you have to. Alright, so let's get into that one. So I have 6, 44.35. So let's see, 6. Oh, I don't use red. 6 goes into 44.35. Now you see my decimals right here? Before I even do anything at all, so I don't get confused and don't get messed up, take my decimal and I put it right up here, right above the other one, top of that line. And then once you do that, the decimal takes care of itself. So then I will do, can 6 divide into 4? No. Can 6 go into 44? Yes. How many times can 6 go into 44? 7, yep, 7 is good. So 7 times. And then 7 sixes are 42, and I subtract. And then 4 minus 2 is down here, and I have 2, and the 3 pops down. Can 6 divide into 23? Well, we had 4 times 6 is 24, which is too high, so we'll try 3. 3 sixes are 18, put the 18 down here. and subtract again. Borrow from this one. And it's going to be 13, 13 minus 8 gives us 5. This 5 pops down. I'm just going to draw a line here to show you. This 3 pops down. This 5 pops down. And we have 5 down here. Can 6 divide into 55? No, that's close. 6 nines are what? When we subtract that, we get 1. Oh, really? I hate that. So we keep going. We're like, how can we keep going? We ran out of numbers. But we didn't, because we can cheat a little bit. We can do this. Put a 0 up there and keep going. This never ends. So 0 comes down here. This 0 drops straight down. And we get a 10. 6 goes into 10 once. 1 and 10 minus 6 gives us 4. Okay, do the same thing again. We put another 0 up here and we keep on going. And the 0 pops down here. And you'll notice that we have 40 now. And 6 divided into 40. Yep. What do you think? 6, 7 is 42, so it has to be 6, right? 6. And then we go 6, 6 is a 36. Put a 36 down here. Subtract, and we see it's going to be 4. So you see at this point now, it's going to keep on going on and on and on. So it's going to look like this final answer. 6 is just going to keep repeating like that. But they said round up to the nearest thousands. There's tens, hundreds, thousands. So our final answer would be 7.392. There's thousands, tens, hundreds, thousands. Cut it off right there. And let's double check that in the calculator for fun. .35 divided by 6 equals, and you see how it goes, 3, 9, 1, 6, 6, 6, 6, and so on. They keep going at 6s actually. So we're right on the money. So once you realize that this was repeating, and you said thousands, just cut it off into thousands and you're good to go. Fun stuff, hey? I know we all love long division. Let's try another one. Let's try this one. I really hate these ones with 2 numbers in front. Oops. No, not that way. .21 divided into 9.03. Really? Okay, so let's get started. We have 21 divided into 9.03. Take the point right away, there's no point right now. perfectly take it, put it up there on top, and we're done with the decimal. No more worries about that. Just leave it there. Life is good. Can 21 divide into 9? Oh no. No way. Forget it. Not going to happen. Can 21 divide into 90? No. You try 5 times, it's going to be too large. But it can go under 4 times. And 4 times 21. Everyone see where this number is coming from? The 84. Everyone see where the number is coming from? It's the 4 times the number in front, right? Okay, so then we say subtract. And 90 minus 84, of course, gives us a 6. The 3 pops down. And 21 into 63, pretty basic. 3 times, it gives us 63. And this time it's a 0 remaining. I wanted to show you one with 2 numbers in front, in case it doesn't look scary. But again, in your calculator, makes it easy. You just go 9.03 divided by 21. But you know what the biggest mistake I see when using a calculator? So do not, sometimes I hesitate saying do not do this, because when I show you, it might remember it as something to do, but do not do this, which is a very common mistake I see. You see this first paragraph here, 21 dividing into 9.03. One of the most common things I see, people mix these two up. What they end up saying is the exact opposite. So instead of like 9.03 divided by 21, which is the right way to do it, oftentimes I see 21 divided by 9.03. They put these in numbers in the calculator backwards, and they get that number, which is wrong. So it's always this number here, 21, dividing into that number there. And in the calculator, it looks like this, 9.03 divided by 21. So don't get those mixed up in order, because it will mess up your whole day and your whole score. Before we move on to this one here, any questions on division, long division, with decimals? Everybody's fine with that now? It's, again, the only difference is between regular long division and long division with decimals, making sure the decimal's in the right place. As long as you put it over the one in the question, you're good to go. So then talk about something called simplified multiplication and division of decimals. What that really means is this right here. I'll just copy this. So what I'm really talking about is down here, multiplying by 10, 100, or 1,000. Okay, when you multiply by 10, 100, or 1,000, or dividing by 10, 100, or 1,000, you can just move the decimal places, 1 place, 2 places, or 3 places, to the right or the left, and if you're multiplying or dividing. If you're multiplying, the decimal place moves to the right, if you're dividing, it moves to the left. Let's try some of these. Let's look at number 8, question 18. Oops, no, not that. look at for 7. Okay, so I'm going to use, I'm going to get a bit bigger, I think. 75.3 times 10. So when I see this one here, multiplication, what I'm going to do, I'm going to actually move the decimal one place to the right. So this equals 753. Like that it looks. 753. Down here, you see it's, well, the easy way to think about it, there's 2 zeros, move 2 places, 1 0, move it 1 place. So down here I got 14.23 times 100, move the decimal place 2 places, 14.23. And you want to see the decimal, it's right here and right there. Next one down, it's going to be like this, it's going to be 2280.5, and it moves 1 place. Down here is going to be 7428. I move it once, twice. There's no other spaces. That's when I use my 0. Put a 0 in there, and we're good. Down here the answer is simple. It's going to be 9. Here's going to be 5.23. And here is going to be 40.507. So basically they're pretty simple, just move the decimal places by the number of zeros you have, you know, when multiplying. And the other source of error that I sometimes see is people moving the decimal the wrong way. Notice the decimal moves to the right. Think about it, it should make sense. If you're multiplying by 1,000, you should have a larger number. So that should make sense. So that's multiplication. Let's look at division. Simplified division. Let's jump right into some questions. So, take this up here, make this a little bit larger. Okay, what do you think the answer is going to be for the first one? 48.5 divided by 10. Because it's going to move, it's going to move 1 place. So it's going to be 4.85. So it moves 1 place to the left. Down here we have 3.08 divided by 100. So it's going to be 0.0308. Has to move 2 places. 1, 2, and that's where the 0 here comes in. Right there. 250 divided by 10. Move the decimal place 1 place. It's going to be 25. Here we have 3 zeros. Decimal's going to move 3 places. 1, 2, 3. And the answer is going to be 4.34902. The bottom one is divided by 10. The decimal again is going to move 1 place over here. It's going to be 0.0035. 2 zeros here. Going to move 2 places. 1, 2. It's going to be 1.752. And down here, 2 decimal places. It's going to move twice again. We're going to have 0.254. And we're all good. Life, everyone's happy. And we got people smiling over here. Yeah, no confusion here. Sorry, didn't divert it there. Who is that guy? Bye-bye. Alright, so multiplying, dividing by 10. Pretty basic. Move decimal place right or left. No big deal. No sweat. Alright, I was gonna think about putting this off, but what's coming up is gonna be a little bit worse, so we'll start on this today and we'll continue on with the next class. Let's have a look at changing decimals into fractions. What? Do we have to? So you thought you didn't like fractions? They're not going away, they're back again. We can change a decimal into a fraction by doing this. Changing a decimal to a fraction requires the use of decimal places and placing the numbers in the fractions that represent the same numbers. So for example, we have 0.475 in a fraction. We see that we also got to know the place value. Remember we talked about place value earlier in this chapter, or the last chapter? Got to remember that as well, because we have 0.475, so we have tenths, hundredths, thousandths. So what we do, we take the tenths, hundredths, thousandths, we have 457 divided by 1,000. And that's the same number because in a calculator, if I did that, I'm going to have 457 divided by 1,000. That's the fraction part. If I hit enter, I get the decimal part. Are we cool with that? Alright, let's try some of these questions. So it says convert the decimals to fractions and reduce if necessary. Let's look at number one. Number one says decimal 0.8. So number one, it's going to be 0.08. When we know the place value is going to be 8 over 100, because it's tenths, hundredths. Okay, we all happy? And now we can reduce that. Because 4 divides into 8 twice. And 4 divides into 100 25 times. And just to show that we're not doing anything bad or wrong, we took a 2 over 25 into 2 divided by 25 and enter. We get 0.08. Same as before. So if we did that and got a different answer, we made a mistake. Something's wrong. Let's go number 2. Okay, in a second we go. There we go. Number 2. I missed that. So we have 0.075. Number 2 gives us 0.075. In our place, that means tenths, hundreds, thousands, which means it's going to be 75 over 1,000. And we know 75 can be divided by 25 and solve in 1,000. So 25 and 75 goes 3 times. And 40. Double check that. Yep, sounds good. So 0.075 actually turns out to be 3 over 40. And we can't reduce that any further. Awesome. Let's look at number 3. Number 3 is 14.2, which for us means 142 over 10. And 142 can be divided by 2. 71. So if I were to divide 5 into 71, I get 14, which gives me 70, and I have 1/5 left over. And to double check that, I can see that 1 divided by 5 is 0.2. And look at the last one. It's 3.75. Number 4. 3.75. We know that's going to be 375 over 100. Tens, hundreds. That's cool. We can reduce that to 375 divided by 25 gives us 15. 15, and 4 into 100 gives us, 25 into 100 gives us 4. So I have 15 over 4. And we want to change that into an improper fraction, or to a mixed number. 4 will divide into 15 3 times, which gives us 12, and 3 over 4 left over. There you go. That will be converting decimals into fractions. Tomorrow's class, you're not going to miss. It's going to be involving converting fractions into decimals. Exact opposite. So just to show you where we are in terms of this chapter right now, looking down here, this chapter number 2, 3, decimals. We're right here. We just finished converting decimals into fractions. Now we're going to convert fractions into decimals. So we only have 1, 2, 3 units left. If we're not finished by tomorrow, we'll be finished by Friday, for example, for sure. So there'll be a test next week in chapter 3. put the assignment online as soon as I get a chance, and work on it as you see fit. Have a great day.